Good afternoon, ladies and gentlemen. Welcome to Math 10C, Chapter 7 Review. Kristen spent $131 on shirts. Fancy shirts cost $28 and plain shirts cost $15. If she bought a total of 7, then how many of each kind did she buy? Can we turn words into equations? Well, let's look at this. She spent $131 on shirts. Fancy shirts cost $28 and plain shirts cost $15. She bought 7 of them. So, $131 on fancy shirts, but each fancy shirt is $28, and each plain shirt is $15. 7 shirts in total. Some of them are fancy, and some of them are plain. So, we can turn words into equations. Can we solve the equations? Yes, we can, but that's not what I want to do yet. Next thing I want to check is, if I give you solutions, possible solutions, can you check them? So, for example here, what's the solution for the following system of equations? 4 possible solutions. We're going to try them all. So, let's check each one of them. So the first one, x is minus 4 and y is 5. So let's check. X plus 2y equals 6. Every time I see x, I replace it with minus 4. Every time I see y, I replace it with 5. Minus 4, 2 times 5 is 10. Minus 4 plus 10. You owe somebody $4, you have $10, you're down to 6. 6 equals 6. So the first equation, the first part works. Oh no, you Shazbot, stop that. I don't know. Make a little more space. The second equation, x minus y equals 12. Let's plug those numbers in. Minus 4 minus 5 equals 12. Minus 9 does not equal 12. So A does not work. Let's try B, 10 and minus 2. So x plus 2y equals 6. 10 plus 2 times minus 2 equals 6. 2 times minus 4. Sorry, 2 times minus 2 is minus 4. 10 minus 4, you have $10, you owe somebody 4, you're down to 6 equals 6. Yes, the first half works. What about the other equation? X minus y equals 12. 10 minus 2 is 12. Well, 10 minus 2 is 10 plus 2. And 10 plus 2 is 12 equals 12. So yes, B works. But I'm being paranoid. Let's check C and D just because dumb happens. Plus 2y equals 6. Every time I see x, I replace with 6. 2 times 0 is 0, so 6 plus 0 is 6. 6 equals 6. First half works. Let's look at the second half. X minus y equals 12. 6 minus 0 equals 12. 6 minus 0 is 6. 6 is not equal to 12, so C doesn't work. Let's look at D. 12 and 0. X plus 2y equals 6. 12 plus 2 times 0 equals 6. 12 plus 0 equals 6. 12 and 0 is 12. 12 does not equal 6. So D does not work. And I'm not going to bother solving the second half. Right? Now, how do we get those solutions? Where do these numbers come from? Minus 4 and 5, 10 and minus 2. Or how do we solve these word equations? Well, there's 3 ways that I expect you to know. The first is solving systems of equations by graphing. Now with graphing, it's always y equals. So for this first equation, minus 3x plus y equals minus 4. How do you get y all by itself? That is, how do you get rid of minus 3x? Well, add 3x to both sides. This becomes y equals 3x minus 4. Now, this goes right back to chapter 6, graphing. Your b value is minus 4, and your m value is 3, your slope. So you go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And you draw a line connecting your dots. Now, I was going to say, I'm going to get rid of the, Shazbot. I'm going to get rid of this dash line because it confuses me. And I'm old, I get confused easy. Anyway, this is y equals 3x minus 4. Now the other equation, minus x minus 2y plus 6 is 0, we have to rearrange that so it's y equals. Now we did this back in chapter 6. This is the general form, something equals 0. So how do we get rid of minus x? Well, I'd add x to both sides. How do I get rid of plus 6? I'd subtract 6 from both sides. So now I'm down to minus 2y equals x minus 6. Now, the big question, how do I get rid of times minus 2? Well, divide everything by minus 2. Now, minus 2 minus 2 is 1. We're down to just y. Now, 1 divided by negative 2 is negative 0.5. Negative 0.5, math, fraction, enter, is minus a half. And I prefer minus 1/2 x. Now, minus 6 divided by, minus 2 is 3. Yes, a negative divided by negative is positive. 6 divided by 2 should be 3. Now, this is my b value, and this is my m. So I go y equals 3. And I screwed that up, didn't I? I can hear you screaming at me. Thank you. I screwed that up badly, but I'm not going to erase this. I'm going to go back here. B is minus 4, not minus 1. What was I smoking when I did that? Oh, dear. I go up 3 and over 1. Up 3 and over 1. Up 3 and over 1. I can hear you screaming at me. Yes. First one that comes to class and laughs at me politely, whatever. Anyway, I would have cut that because we're about to check that on the graph. Anyway, embarrassing. Anyway, life. Anyway, double checking this. B is 3 plus 3, and my slope is minus a half. I go down 1 and over 2, and there we go. Down 1 and over 2. So there's my line. And where does it cross? Right here at x equals 2 and y equals 2, or 2 comma 2. So let's see if I can screw this up. Y equals 3x minus 4 minus 1/2 x plus 3. Graph. There we go. Second, calculate. Number 5. Intersect. Enter, enter, enter. 2 and 2. Yes. Got it right. Actually, I should do that again a little slower. Second, calculate. Number 5, the intersect point. And you scroll over to your roughly where the intersection is. You go first curve, yes. Second curve or second equation, yes. Guessing, somewhere around 2, yes. One more time. X is 2 and y is 2. So I did have it right, even though I drew the wrong graph. No, I caught my mistake and I learned from it. Now, for those of you that don't like graphing, we have substitution. And let's see if I can screw this one up in front of you. Anyway, substitution is when we have one of the numbers that's a coefficient in front of the variable of 1. And then we rearrange that equation so it's 1. In this case, 1y. So, how do I get rid of plus 5x? Well, I'd subtract 5x from both sides. So this equation becomes 1y equals minus 5x minus 17. Now, why do I do that? Because substitution, I go to my other equation. Every time I see y, I replace it with minus 5x minus 17. Let me show you. Minus 3x minus 3y equals 3. Minus 3x minus 3 times, not y, minus, color code this, minus 5x minus 17 equals 3. Now that's ugly, but we all have graphing calculators. Minus 3 times minus 5. Sorry, wrong button. Minus 3 times... Oh, you shuzbot. Clear, clear, clear. Negative 3 times negative 5 is 15. So that is plus 15x. Minus 3 times minus 17. Well, this is why I had you guys doing times tables at the beginning of the year. 51. plus 51 equals 3. Now, that's not bad, but we want to get x all by itself. So how do we get rid of plus 51? Subtract 51 from both sides. Now, what is 3 minus my answer, 51? Notice I don't have to type it out again. Minus 48. Sorry, color code. Color code, Mr. Sutton. Now, minus 3x plus 15. You owe somebody $3, you have $15. I think that's 12. Minus 3 plus 15. It is 12. So that's 12x. Now, 12x is minus 48. How do you get rid of times 12? Divide both sides by 12. So, what is 48 divided by 12? I don't know, but it was negative 48 divided by 12 is minus 4. So x is minus 4. That's half my answer. Now, I've got to go back and plug that into one of the equations, original equations, and solve. Now, I'm going to choose not 1y equals minus 5x, just in case I screwed it up. I'm going to go 5x plus y equals minus 17, because I can. So, every time I see x, I replace it with minus 4. Plus y equals minus 17. Now, 5 times negative 4 is negative 20. Negative 20 plus y equals minus 17. How do I get rid of negative 20? Well, I add 20 to both sides. So y, what is 20 minus 17? I have $20. I pay somebody $17. I'm down to 3. So y is 3. That's the other half of my answer. So I could write that as minus 4 comma 3 like that in big brackets and be proud. Right? Now, is there a lot of steps there? Yes. Is it possible to make a dumb math boo-boo? Yes. Just like I did a dumb math boo-boo back here graphing. It happens. Learn from your mistakes and fix it. Anyway, so this is substitution. One of the coefficients is a 1, and you substitute in. Now, there is one more way to solve these. I'm going to show you. Elimination. Now, elimination is when you add the equations together and something cancels out. So we're looking for equal and opposites. Now, is minus 1 equal to an opposite minus 1? Minus 4, try that again. Is minus 4 equal to an opposite minus 1? No. Is minus 15y equal to an opposite plus 5y? Well, they're opposite, but are they equal? No. Can I make them equal? Yes. I either divide the top equation by 3 or I multiply the bottom equation by 3. If I multiply this by 3, I get 3 times minus x minus 3x. 3 times 5 is 15y. And 3 times minus 13, oh, no, wrong button, sorry. 3 times negative 13 is minus 39. Now, why do I do that? Well, look at my other equation. Minus 4x minus 15y equals minus 17. When I add these two equations, what do I get? Minus 15 and plus 15 cancel out. Minus 4x minus 3x. I owe somebody $4. I owe somebody else $3. I owe a total of 7. Now, minus 17 minus 39. Got to be careful here. Minus 17 minus 39 is minus 56. Okay, so how do I get rid of times minus 7? Divide both sides by minus 7. Okay, so that means x equals, now minus 56 divided by negative 7. Notice I don't have to type out again. My calculator remembers the answer, and the final answer here is 8. X is 8. Okay? Now, if that's the case, I take this and plug it into one of the original equations. Which equation looks less nasty? Honestly, it doesn't matter. I'm going to choose the second one because I can. It doesn't look as nasty. Minus x plus 5y equals minus 13. Now every time I see x, I replace it with 8. So this is minus 8. Minus 8 plus 5y equals minus 13. Or minus 8 plus 5y equals minus 13. How do I get rid of minus 8? I'd add 8 to both sides. So 5y is minus 13 plus 8. Negative 13 plus 8 is minus 5. So 5y is minus 5. So how do I get rid of times 5? Divide both sides by 5. So y equals negative 5 divided by 5 is negative 1. I thought so, but I thought I'd double check. Because I'm having one of those days. That graphing question was embarrassing. Anyway, so 8 comma minus 1 is my answer. All right, so that's solving by elimination. So when I give you an equation, and I'm not picky about, sorry, sometimes I'll say you have to solve by elimination, sometimes by solving by substitution or by graphing. Or I ask you to decide. So we go back here. 131 equals 28f plus 15p, 7 equals f plus p. Original question. Now, can we solve this by graphing? Yes. F and p become x and y. But I'm going 28x plus 15y. That looks kind of icky. I'm going, we could multiply the top and the bottom by minus 15. Sorry, we could multiply the bottom equation, 7 equals f plus p. If we multiply it by minus 15, then we can get our p's to cancel out. But I'm going, probably substitution is easiest here. And notice I'm going, I think, I'm going to rewrite this just as p. So how do I get rid of plus f? Subtract f from both sides. So 7 minus f equals p. And that I substitute into here. So this is 131 equals 28f plus 15. And instead of p, I write in 7 minus f. Now what's 15 times 7? 105. 15 times minus f is minus 15f. Now, I want to get everything on the same side, so how do I get rid of 105? Well, I subtract 105 from both sides. So 131 minus 105 is 26. So 26, now what is 28 minus 15? 28 minus 15 is 13. So 26 equals 13f. How do I get rid of times 13? Divide by 13. So f, 26 divided by 13. 26 divided by 13, the other 12, is 2. So 2 fancy shirts she bought. So plug that back in, and I'm going to go to the simpler equation. 7 equals f plus p, but every time I see f, I replace it with 2. Okay, so 7, make that a little neater, Mr. Sutton. You do insist students to be neat. 7 equals 2 plus p. How do I get rid of plus 2? Subtract 2 from both sides, so p equals 5. She bought 5 plain shirts and 2 fancy shirts. Now, could I solve that by elimination? Sure. As I said, I would multiply this equation by minus 15. And then you get minus 15p, and you add the 2 equations together. It would work. But what's simplest? I don't know. I like this way. I did it. It works. If you want to do it another way, do it and impress me. Anyway, that's it for Chapter 7. Good luck. I've got a bunch of review questions there for you. Remember, there's some stuff on those PDFs that I can't edit out about number of solutions. Don't worry about that. You're not responsible for that. So, good luck. If you have any questions, shoot me an email. Otherwise, I'll see you in class.